Nanotechnology is the study of the controlling of matter on an atomic and molecular scale. Generally, nanotechnology deals with structures sized between 1 to 100 nanometer and in at least one dimension, and involves developing materials or devices within that size. Scientists debate the future implication of nanotechnology. Nanotechnology may be able to create many new materials and devices, with a vast range of applications, such as in medicine, electronics, biomaterials, and energy production. On the other hand, nanotechnology raises many of the same issues as any new technology, including concerns about the toxicity and environmental impact of nanomaterials, and their potential effects on global economics, as well as speculation about various doomsday scenarios.
Nanoscale materials are sometimes used in solar cells, which combats the costs of traditional silicon solar cells. Development of applications incorporating semiconductors nanoparticles to be used in the next generation of products, such as display technology, lighting, solar cells, and biological imaging. DNA nanotechnology utilizes the specificity of Watson Crick, based to build well-defined structure out of DNA and other nucleic acids. Approaches from the field of classical chemical synthesis, inorganic and organic synthesis. Also, I'm designing molecules with well-defined shape. More generally, molecular self-assembly seeks to use concepts of supramolecular chemistry and molecular recognition in particular, to cause single molecule components to automatically arrange themselves into some useful conformation.
Nanotechnology is very diverse, ranging from extension of conventional device physics to completely new approaches based upon molecular self-assembly, from developing new materials with dimension on the nanoscale to direct control of matter on the atomic scale. Nanotechnology entails the application of fields of science and diverse surface science, organic chemistry, molecular biology, semiconductor physics, and others. Top-down approaches. These seek to create smaller devices by using later ones to direct their assembly. Many technologies that descend from conventional solid-state silicon methods for fabricating microprocessors are not capable of creating features smaller than 100 nm, falling under the definition of nanotechnology.
Holography is a technique that allows the light scatter from an object to be recorded and later reconstructed so that when an imaging system, a camera or an eye, is placed in the reconstructed beam, an image of the object will be seen even when the object is no longer present. The image changes the position and orientation of the viewing system, changing exactly the same way as if the object were still present, thus making the image appear three-dimensional. The holographic recording itself is not an image. It consists of an apparently random structure of either varying intensity, density, or profile. Holography is a technique that enables a light file, which is generally the product of a light source scattered of objects, to be recorded and later reconstructed when the original light file is no longer present, due to the absence of the original object. Holography can be thought of as somewhat similar to sound recording, where areas of files create vibrating meters, like musical instruments or vocal cords, using thought in such a way that it can be reproduced later without the presence of the original vibrating meter.
So it raises the question, are we nothing but information? Is the soul, the essence of who we are, nothing but information? Well, I'm a physicist. We don't know the answer to that. All we're saying is it is physically possible to teleport an entire human being across the room or maybe onto Mars. It is physically possible to do that, and it raises a valid question. What happened to the soul if your original copy died and somebody out there has all your memories? What does that mean? And the answer is, we don't know.